Okay, welcome back to Lecture 8. We are now going to continue with precip types, and I'm going to go through 10 practice scenarios here. Keep in mind, just like anything, you got to practice to get good at this. And if you think you're going to become an expert from one lecture and 10 files, that's impossible. It takes years and years of practice. But I'm going to give you the mechanics and the basics and the way to start so you can build from it. And I'm going to show you how to go about this. All right, so we're going to break this down. We're going to go from the top towards the bottom, and we're going to break each one of these scenarios down. Hopefully you have downloaded BuffKit, and I'll put the files in the class so you can upload those files and kind of go along with me with this. And if not, I do actually took screen captures and have the BuffKit files or the actual screen captures in there, so you could also follow along that way as well. Again, like I told you, don't want to keep dwelling on this, but I do highly recommend that you download BuffKit. It's really going to help you, so it's worth it. All right, so let's go through some practice soundings, all right? So we're going to work through each scenario, and I would like you, obviously I'm going to put notes there, and you're going to have them with you, and it's going to help you, obviously. But if you look at the notes first before looking at the sounding, then you're probably not going to learn this as well. So I would try to look at the sounding first and then refer back to the notes, okay? So it's kind of like if you did a forecast. Don't just read the weather service discussion first. Do your forecast first before you read that discussion. And make sure BuffKit is set up to display elevation in thousands of feet, all right? You don't want kilometers or pressure. You want elevation in thousands of feet, okay? And I talked about that in the tutorial. All right, so we're going to look at either snow versus wet snow, sleet, freezing rain versus drizzle, rain versus drizzle, sleet and freezing rain mix. All right, so these are the scenarios we're going to look through. All right, so the first sounding, we got Columbia, South Carolina. We're looking at hour 18. And like I told you, this is all the notes I was talking about, right? So I'm putting notes with each sounding. That way you can listen to me go through it, and then you can practice yourself as you pull up the files and look at it. And you also have notes to go along with it, all right? So hopefully this is helpful. This is going to take some time to get good at, all right? If you wait to the last minute on this unit, you're probably going to struggle, all right? I've seen people in the past wait to the last minute, and that is a big mistake, especially on this unit. If you come, hitting me up the last night before it's due or 24 hours before it's due, I'm not going to have a lot of sympathy because I've really gone out of my way to give you a lot of practice soundings. I try to give you a lot of notes. I put all the files in there, and I give you a lot of time to do this, all right? So I hope you get started with this early. For some of you, maybe you live in an area where you get a lot of snow and you've already kind of done some of this, then maybe this will be easy for you. But for others, maybe this is going to take some time, all right? And even if you are familiar with winter weather, maybe you're not familiar with the details of really breaking it down like we are here, okay? So I just wanted to say that before we kind of get going on this. All right, so again, Columbia, South Carolina, hour 18. What's the first thing you always want to do? Well, the first thing we want to do is we want to identify where your snow growth region is. And you see minus 12 to minus 18s in that range here. You kind of see it with these little lighter blue colors here, and that's your prime region. And then here's minus 10, that dashed blue line going up. That is what we're using as our snow growth region. We've talked about this in the lecture. We know it can happen as warm as minus 5 and as cold as minus 15, but minus 10 is a safe baseline, and this is what we're using for teaching purposes and what we're using to forecast. This is what I've been using for the last 15, 20 years, and it works very well, all right? So minus 10 is a safe baseline. So the first thing you do is you go up the minus 10 degree line here, and you look and see if it's saturated. And it does look saturated, but always double check it on an overview, all right? Always look at it, pull up the snow growth region, and make sure it's saturated. So we're looking at 6C on Thursday, all right? And I already have the image up. So here is overview. You would click on relative humidity, and then you would go under contour and click on snow growth, right? So we're looking at 6C on Thursday, all right? So 6C on Thursday. So you see a little pocket of drier air, all right? But one thing to consider, let's look at these two pink lines, all right? This bottom pink line is the minus 12. This top one is minus 18. The shaded area here, yellow, is showing saturated, right? So even though this isn't shaded in, keep in mind this is the -12 line. So really your -10 is a little bit below that. And anytime the moisture is really close, like within 1,000 feet or so, I'm going to be fairly confident that we do have enough moisture to make snowflakes. All right. So in this scenario, we are close, but since this is the -12 line and we know it's going to extend down a little bit more because we're looking at -10, not -12, we have moisture in the snow growth region. We're making snowflakes. All right. So if we're making snowflakes, everything's on the table. So now what do I need to do? All right. We've assessed the snow growth region. We're making snow. What is the rest of the sounding doing? All right. Do we have a melting layer? We do, but how big of a melting layer is it? Maybe, I don't know, 500 to 1,000 feet, and we only get to 0.3 degrees Celsius, all right? So are we getting to 1,500 feet? No. Are we getting to 1? No. So we have a little bit of melting, but we're not getting in that partial melt zone. We're not getting in that 1 to 3 and 1,500 to 4,500 feet. So this would be that stinging snow I talked about, where you have a tiny, tiny little bit of melting, but we're not in that partial melt zone. And even though the snowflake might be a little bit icy, it's still going to have the appearance of a snowflake, all right? So if you go back to the notes, I even write snow and stinging, and I break it down for you right here so you can look at it in more detail. All right, so it's not overly complex once you get the hang of it. And as we go through a few more, I think you're going to kind of be like, all right, I'm starting to get this. This isn't so bad. All right, so next one, we got Hickory, North Carolina. We got hours 9, 10, and 11, all right? So let's just go hour by hour on this, all right? Hour 9, first thing you want to do, same thing. We're following the -10. Where we get to the -10 up here, we see it's saturated. But again, always be careful. Let's look at it in overview. Let's double check. So in overview, we're looking at 9Z on Thursday. So let's look at that. 9Z Thursday, we have moisture in the snow growth region. We are good to go. We're making snowflakes, all right? So we know these snowflakes are falling, and then they encounter what? There's a melting layer, right? And this melting layer is a lot. So we need to analyze that melting layer. Well, what do we get to? We get to 1.9 for about, 1 to 2,500 feet. So we're in between that 1 and 3, and we're in between pretty much the 1,500 and 4,500 feet. So what are we in? We're in that partial melt zone. So when you're in that partial melt zone, what do you need to do below it? You need to look at the sub-freezing layer below it. So how cold do we get? We get to -4.3. Now in the lecture, I told you at -5, you're 100% safe. But from my experience and from a lot of practice of doing this, I feel like you're pretty safe even at -4. So if you're in that -4 to -5 zone, you're looking at 100% sleet, okay? So this is a sleet sounding. Now, what if you didn't quite get to -4? What if you were like -3.5? Well, then maybe you would have a mix of freezing rain and sleet because you are below freezing at the surface, all right? So let's keep that in mind as we move on to the next one. All right, hour 10. Again, we still have all the notes here for you. All right, so we know there's moisture in the snow growth region. We've already looked at that in overview. We're only going an hour up, so we know nothing's changed there. We have a melting layer. This one's a little deeper and it's a little bit warmer, right? So it's about 1,000. It's closer to 3,000 feet, and we do get to 2.9. So I still think at this point it's still sleet, but you're getting closer, right? Because below it, you're only at -4.1, so you're kind of borderline there. You're almost to 3 here, and the thickness is kind of in between 1,500 and 4,500 feet. So since we're kind of in the middle on the other one, and we got 2.9 here, I would still lean to sleet here, but you could argue at this point maybe some freezing rain is starting to mix in there, all right? But for me, I would still lean sleet at this point, all right? Now, on the quiz, I wouldn't give you something really, really close like this. It would be more obvious, all right? Most of them are going to be pretty self-explanatory. If you understand the lecture and you understand these practice scenarios, you should be able to pick it out fairly easily, all right? There may be 1 or 2 that's a little bit more complex than the others, but in general, they're going to be pretty, I don't want to say obvious, but if you understand this, you're going to look at it and go, okay, I know what that is. I've seen this, all right? I understand. So let's look at hour 11. Now by hour 11, let's look at the depth of that melting layer. It's still probably about 3,000 or so feet, maybe a little bit more. But what's happened? We've now at 3.9. So now that we're so close to 4, this is most likely a total melt. And our surface temp is minus 1.7, so we're really close to that minus 2. Remember, minus 2 is really important here, but this is a freezing rain scenario. Now, one thing to keep in mind, we're breaking this down hour by hour by hour. Would you go on air and go at 4 a.m. it's sleet, at 5 a.m. it's freezing rain, at 6 a.m. No, you wouldn't break it down like that. Don't give exact times. Don't go sleet changing to freezing rain at 5:20 a.m. No, don't do that. Say sleet changing to freezing rain during your morning commute or during your morning rush hour, that type of stuff. Give yourself a little leeway there. A few reasons. If you do give exact times, you're only going to set yourself up for disaster because people are going to call you, people are going to hit you up on social media and be like, hey, you said 5:15 or 5:20 and it didn't happen. So don't do that. Give yourself a little bit of a leeway because obviously there's no way to be that precise on this. And also, it depends on your viewing area. If you live in a massive city, your western suburbs may start seeing a changeover a lot faster than your eastern suburbs. So keep that in mind, all right? You want to be a little more general when it comes to that. All right, next one, Charlotte, North Carolina. Got the notes there, so you can refer back to that. So let's look at this. All right, minus 10, we're following it up. Looks pretty good to me. Looks like we're saturated, but let's double check. We're looking at 11Z Thursday. We go here, 11Z Thursday. We are completely saturated. We are making snowflakes. We're good to go. So now we need to assess the melting layer. Well, what do? We get to 6. All right, so it's over. We're already over 4. If it's over 4, it's done. And you know when it gets that warm, it's going to be deep enough as well. So we're at 6. We're at total melt. Now all we're doing is looking at the surface. We look at the surface. We see it's minus 0.5. So this is freezing rain, but is it a damaging freezing rain event? No. This is bridges and overpasses and power lines and trees. Exposed surfaces, right? At the surface itself, that minus 2 is really important. So the ground is not an ice skating rink, but you still have problems with bridges and overpasses, which you do need to emphasize, especially down here in the South. People aren't as used to driving in winter weather, so a lot of times when they hit a slick spot on a bridge, people slam on their brakes and get themselves in trouble quickly. So it's still, depending on where you are, can cause a lot of problems, but this isn't the ice skating rink scenario, all right? And I definitely put more of the notes there that I've already talked about. That minus 2 is really important. And not just the minus 2. You really need that northerly component of the wind to offset the latent heat release during freezing, all right? When that freezing rain is occurring, it's releasing latent heat. And if you don't have that northerly flow, especially down here in the South, but even in most places, maybe you can get away with it, way up north or Canada or places like that, where it's just really exceptionally cold and the ground is completely frozen. But in general, you really need that northerly component of the wind to offset the latent heat release. And minus 2 is a really critical temperature. You start getting minus 2 or colder, and it's over. It's an ice skating rink. All right, and the ground temp is very important. We talked about that also in the lecture. So, make sure you don't overlook that. If it's been 60 degrees for the last 2 weeks, keep that in mind. All right, that's something to remember. And also, just because it's 32 doesn't mean it's full panic mode. All right. Again, exposed, elevated surfaces, all right, there might be some issues, but the ground itself is not going to turn an ice skating rink. All right. So just make sure you keep that in mind. All right. Don't want to hype things. You want to keep things. You want to be calm with everything. All right, so we got to clear Wisconsin. Let's break this down. All right, let's look at that snow growth region. Minus 10, we got moisture in the snow growth region. Looks good to go. But let's double check. 11Z Saturday. All right, 11Z Saturday, we got moisture in the snow growth region. We're good to go. We're making snowflakes. We're making ice crystals, all right? So now what do we need to do? Well, do we have a melting layer? We do. But what is different about this compared to the other ones we looked at? The melting layer is not a lot. The melting layer is at the surface. And what did I really emphasize in the lecture? This is the physics versus the human element to it, right? Yeah, there might be still an ice crystal in it, but are you going to see it? No, it's just going to look like rain to you, right? So what is the baseline we use? If the wet bulb zero is above 1,000 feet, we're going with what? Cold rain. If it's below 1,000 feet, we're going with wet snow. So on the quiz, if it's 1,001 feet, it's cold rain. If it's 999 feet, it's wet snow. We know there's a range because of the snowflake size. It's somewhere between 900 and 1,500 feet, but we're using 1,000 feet, all right? So I want that clear on the quiz. I don't want people to come to me and go, oh, you said there's a range between 900. No, we're using 1,000 feet for the quiz, okay? We got to pick a baseline, so that's the one we're going to use, and that's the one I always use usually anyway. All right, so let's look at it. We know that the melting layers at the surface, so it's only either wet snow or cold rain. So let's look at the indice, right? So you would go up here and click on indice, which I've already done. And now let's look at the wet bulb zero height. Are we below 1,000 feet? Yes, we're 435 feet. So this is wet snow. Not too tricky, right? Like once you start getting the hang of it, hopefully now you're like, okay, this is starting to make sense. All I got to do is follow up the -10, make sure it's saturated. You know, if it's below, below 1 and 1,500 feet, I know it's maybe that's stinging snow, but it's still snow. If it's between 1 and 3 and 1,500, 4,500 feet, you're in that partial melt, but I need to look at that sub-freezing layer. I need to make sure we're getting down to -4 in order for sleet. If it's between -2 and -4 where I got that mix, and if it's less than -2.5, especially if this, well, as long as the surface is below freezing, then it's freezing rain. If you're above 3 to 4, especially 4, because again, it depends on the size of the flake, and you're above 4,500 feet, total melt. So hopefully now it's starting to click, right? So this is wet snow. And again, I had the notes for you right there on that. All right, next one, Columbus, Mississippi. I actually remember this event. So let's look at this one. All right, so let's follow that -10. Well, that's a little bit more questionable, right? Like, you don't look at that and go, oh, that's saturated. You're like, I don't know. So let's look at this a little bit closer. 3Z on Saturday, all right? So 3Z Saturday, let's look at it. That's just too far. Now, look, you see here it's 6Z and 7Z where it's close. Okay, fine. That's close enough because we know that's -12, and this is -10 extending down, so we're probably good to go. But 3Z, I don't know. We're pushing probably 3,000 feet of dry air here. So I think it's very unlikely that there's enough moisture at this point to make snowflakes, all right? So there's no moisture in the snow growth region, which means what? If there's no moisture in the snow growth region, you can't make snow, you can't make sleet. Your only choices are what? Freezing rain or rain, but to be more precise and more accurate, it's actually what? Freezing drizzle or drizzle, because look at how shallow this cloud is, right? This isn't some deep cloud, right? So let's break this down. All right, so we know that there's no moisture, so now all we need to do is look at the surface temp, right? Surface temp's 2. So what is this? This is drizzle. Now, why did I put this in here as well, where you see the wet bulb zero height? Well, because I think maybe some people might overlook this and see the melting layer of the surface, pull up the wet bulb zero height, see it's below 1,000 feet, and answer this as wet snow. But it can't be wet snow because you're not making crystals, all right? So make sure that you don't get tricked on that, all right? So again, this is drizzle, right? Because it's above freezing. If it was below freezing, it'd be freezing drizzle. All right, Minneapolis, Minnesota. Let's break this one down. Same problem as the last one, but now it's way more obvious. I mean, you almost don't even need to look at overview, but still, let's do it. Let's be smart. Let's always look at it to be sure. 16Z on Sunday. Let's look at it. You got some high-level moisture, but look at that gap. I mean, you're talking 7,000 foot gap here, all right? So there's no moisture in the snow growth region. This is about as obvious as it gets. And what shallow cloud you have, it's pretty shallow there. So you're either going to have what? Drizzle or freezing drizzle. So we know no moisture is being made. There's no ice crystals. So you can't get snow, you can't get sleet. So let's just look at the surface temp. It's below freezing, so this is freezing drizzle, but is it a devastating event? No, because it's not -2, but bridges and overpass and trees and things like that, all right? So again, this is not overly hard once you get the hang of it, and I got the notes there for you. So again, just go through these, practice with them. It may take a couple times. You may need to go through the lecture a couple times before you really click on this. And again, don't wait till the last minute. That's my #1 advice with this. And I'm here to help too. I'm always available. I pretty much answer questions Monday through Sunday. So if you have questions, just let me know and I'll help you the best I can. Now, don't put it on the discussion board. Don't go, hey, I think it's this. No, don't do that. If you want to be more specific, then email me. Don't put that on the discussion board. But of course, I'll help you the best I can. All right, Dallas, Texas. This is that weird sugar sand snow. I'm not going to spend an overly, a big amount of time on this because I'm not going to quiz you on this. But I just wanted to show it to you so you don't think I'm making these things up. These things do actually happen. So what do you want to do? Same thing, same process. -10. Do we have moisture? We're looking at 1Z on Monday. Yep, we are good to go. We got moisture. But what do we got? We got a big melting layer here. And we get to 3.8 for 1, 2, 3, 3,500 feet. Since we're so close to 4, this is likely a total melt. Could maybe 1 or 2 still have an ice crystal in it? I guess it's possible. But when you're getting close to 4, and especially if you're 4 or above, it's over. With it being this close, this is likely total melt. But this is that weird scenario where, yes, it's wrong to say that rain spontaneously freezing in the air is sleet, because I've taught you now that it's partially melted snowflakes that are refreezing into sleet. But this is that weird thing where the rain can spontaneously freeze because it's so cold, and this is rare, especially in the lower 48, especially in a place like Dallas. All right, this is not common. You're rarely ever going to see something like this. It does happen. I've seen it in DC. It's kind of the sugar sand snow. It's this super fine grains. It's almost like these little crystals. I don't even know exactly how to describe it to you. I've only seen it once. But this is that weird example where you get cold enough that you probably do have spontaneous freezing here, and you would get this really fine grain sleet. All right, I'm not going to test you on it, but I just wanted to show it to you just so you can see a scenario where that actually did happen. All right, last one here. Elmira, New York. And let's break this one down. All right, so -10, let's go up. All right, what do we got? It looks like we're pretty saturated to me, but let's look at it in more detail. Let's go back. That's 6C on Tuesday. Let's go 6C Tuesday. All right, we got plenty of moisture. Not even an issue, right? So now I'm looking at this, and I want to assess the melting layer. Well, where is the melting layer? It's at the surface. So this isn't a loft. This is at the surface. So if it's at the surface, it's either what? Wet snow or a cold rain, right? Well, let's pull up the indice. Like, you would go up here, you click on the indice, which I did, and where are we? We're 1132, all right? So we're using the baseline of 1,000. We're above 1,000. This is a cold rain, all right? And I have that in the notes as well, okay? All right, so hopefully this was useful. I think it's probably going to be helpful, especially when you break it down and you take the files out and you go through it. You don't have to have the files to be able to get through this and get through the quizzes. I'll put all the files up. But if you want to get better, and again, I've said this enough, you really want to download BuffKit. And, again, look at, I have all these, notes. I give you all these slides and practice soundings. I'm going to put everything in the class. You have me as a resource. So I will help you the best I can. And hopefully, you find this pretty cool. Even if you're not in an area where you get a lot of winter weather, it's still useful. And like I told you, like a place like Mississippi, you blow a snow forecast, you're going to hear about it for the next year or so. All right. So it's good to know this. It's good to get, the best. I mean, no one's perfect, obviously. I mean, shoot, I get 1 out of 3 wrong. But you try to do your best, and this will help you at least have the baselines to be successful. Okay, so you have all the notes, you have all the files, and I'll be back here with lecture 9, which will be snow ratios.